All right, hello. As the conference tradition demands, I made last minute changes to the slides. I even changed the title because I thought it was cute that it's the same as it would have on the back, and now I realize it's maybe a bit embarrassing, but well, never mind. Yeah, my name is Lovis, and I'm working as a software engineer for Circus. We are a kitchen tech company, and I'm involved in the robotics department of that company. So. Here you see AidMe. If you want to talk about that, we can talk about that later. But for now, we're Circus. All right. When you think of robots, what is it we think about? We probably think of some humanoid thing with arms and legs and whatever, dancing or fighting, I don't know. But maybe you're more into animals, so you might be thinking about dogs, robot dogs, I don't know. Since we're kitchen tech, you probably think of something like this. Some automated cooking thing. It's not a real robot, but at least it's autonomous. In the service area, maybe you already have seen something like that. These cute little cats which go around restaurants and say, "Hey, here's your meal, please pick it up." Super cute. But in reality, most robots aren't that cute. Most robots are actually just arms on an assembly line. And even more general, just arms, because the assembly line is not part of the actual robot. So my wonderful colleagues from Munich, they took these arms and they put it into an automatic kitchen cell. You can see the one robot arm is holding the pot, and the other one is just waiting there to actually take over the pot and serve the dish to the customer. Okay, but I'm not a mechanical engineer. What I am is a software engineer. So when I think of robots, at the moment at least, I think of an API. It's just that, just some API spec. But before we dive deeper into that, maybe first ask the question, what actually is an autonomous kitchen cell? Because I'm not sure if everyone is familiar with that concept. So it's actually just a huge box. And then we have two robot arms inside. We have one for cooking purposes and one for serving the dish in the end. Then there's a bunch of cooking stations, which are pots rotating on heating plates, so the dishes can actually be cooked. And we have the silos where the ingredients are in, so pasta or chicken or tomato sauce, whatever. But there's also a huge amount of sensors inside, like, for example, temperature sensors or movement stuff. And to control all that, you need a computer. And that computer is called a PLC. If you're familiar with hardware, you might have heard that before. It's a programmable logistics controller, actually a pretty hard word. And this provides kind of low-level commands to the machine. It's not like you're sending integers or something. There is an actually SDK, but it's super low level. It's not like an API we saw, a REST API. So there's something we're still lacking. So how do you actually put a robot into the cloud? But before we answer that question, we should maybe ask why even put a robot into the cloud, because this might be a more interesting question, philosophically at least. First thing is you want to be able to control it. You don't want people going there every day and manually operating the robot, because that would kind of defeat the purpose of a robot. You need logs and alerts because you want to be the person who knows first when something is missing, it goes wrong, whatever. Monitoring, same thing. And one often neglected thing is you want to be able to deploy patches, because when you think of your car, you go and they have a software update for your car, you have to go to the manufacturer and they silently just deploy it, or maybe they don't. So you want to be able to do that via the cloud, via pipeline, regular software stack here. But there's, of course, also the more non-technical side of the things. I have a cooking robot, so I want to be able to order from an app. So how to do that without an API, without the cloud, is probably not feasible. And I also want to know what the status of my meals is. All right, so back to cloud. How does this work? So when the customer wants to order something via the app, you say, hey, please give me this curry. Bing, goes to the cloud. It's being processed. Stock keeping is updated. Payment related things are done. And then it goes to the unit and it's being cooked. Pretty simple, right? When I talk about the cloud, what I mean is actually just a bunch of containerized Spring Boot apps in AWS ECS. Nothing really too fancy. Using relational databases. Really, it's really solid stuff. Nothing too fancy. Not no lambdas, but almost no lambdas, for example. So you see the different domains here. Just as examples, we have payment, which is obvious what it does. Stock keeping, also kind of obvious. But the actual stock is only living in the unit, obviously, because that's where the food is stored in. But it's always a good idea to have like a virtual copy of that stock in the cloud, so you can make quick decisions for whether something is sold out or something. You don't want to wait for the actual update of the unit. You also don't always want to reach into the unit for asking, hey, how much stock is left, because that would be super slow. Then there's user management. If you have an app, you probably have users. And the point of sale, which basically orchestrates everything. It's the gateway for the apps. And the core of everything is unit control, which, surprise, controls the unit from the cloud. So when the order goes in, the point of sale system does this orchestration, and then it publishes an event, hey, there's a new order created. But there's a problem. I already told you the PLC is a very low-level API. It's no REST API. So what's the way around it? Simple. First of all, the thing needs to be inside a network, which will be a VPN. And inside that network, you put a Raspberry Pi and you deploy another Spring Boot app on it. Easy. This is the unit app, and the unit app is responsible for hardware abstraction, like I said before, but also for like business logic, like scheduling. When should which dish be cooked, in which order, when is it done? And also, could I reuse a pot or should I wash it first? Because there's actually also a washing system inside. And the important thing for me as a software developer is it provides the API, the REST API. All right, so when a REST call is made, then the unit app does its thing. It's calling to the PLC, sending the robot commands, say cook this, cook there, and then we get lots and lots and lots of updates via AMQP. This is also basically standard in IoT devices, that you have some sort of MQTT or AMQP protocol here. The point is it's not synchronous, it's asynchronous, and it also works offline, because if it would be a synchronous connection, the connection stops, then what to do? Like this, we just say, hey, please do this unit, and then we'll just respond some day later, not day, some, that would be bad, some moments later, whenever it has connection with the actual updates, which could be stock updates or cooking job updates. So, hey, now it's cooking, now it's finished, now you can pick it up, and things like that. Also, we regularly push metrics and logs to CloudWatch, which makes totally sense because, as I said before, you want to be able to monitor the whole thing. You, for example, you want to make sure that the cooling chain is always it's always cool inside. So you need to basically log every temperature change, and you need to make it public for some operator to observe it, whether you have to do something there. But actually, it's not that easy because, in fact, I lied. It's not the unit control that actually does the things. There's something between, which we call the unit proxy. This proxy has three main functions. The first is pretty simple and maybe not that important, but it's nice to have. The unit would, the cloud would usually just say, okay, please, I want to cook this meal on the unit code localhost, which you can also find on my back. And then only the unit proxy actually knows how to route this. So maybe a bit like service discovery, but only very, very dumb, actually. It's just a database. And this is the first function. The second function is that, as I said, it's in an own network, and you can't reach it from outside for obvious reasons. Unless you're in a VPN, you can't actually reach it. The same is true for the cloud itself. So you can't like go into our cloud and then just try to reach the unit and send dangerous commands or something. So we put this proxy in between, which is essentially deployed in the own subnet that is allowed to reach the other subnets, the unit subnet. Yeah, we saw that with ACLs on the subnet level and appropriate load balancer settings for everything else. Like I said, nothing too fancy, actually pretty groundwork. And the third use of this proxy is authentication, authorization. Well, we have normal authentication, authorization also at the API level, and in between the services, this provides an extra layer because interaction with the robot can be dangerous. You could potentially kill somebody, actually, if someone's just inside and cleaning or whatever. Or you could, though there's actually hardware safety, so it can't happen, but you never know. Or you can even just break something because you do something that is not intended at that time of the process. So everything you need to do with the robot needs to be authenticated extra with a second factor, like a YubiKey, for example. And this is also what the proxy helps us with, because it actually mirrors the API of the unit app, and it knows, okay, all these URLs are super critical, so only reach them when you have the appropriate level of authentication. Yeah. And otherwise, it just says, nope, you are not allowed. This was one unit, but one service, well, we could say one service is microservices, but usually you have it load balanced. But we don't know if you have it load balanced. We also have just a whole kitchen fleet. We have multiple units running mostly in Berlin. And here you see this is similar to a microservice architecture. So you can see, okay, title of the talk. So to answer the question from the beginning, how to put a robot into the cloud. The most important thing is make it part of your infrastructure. If you think, oh, this is just a machine, I can treat it like any other machine, you have already lost. You need to make sure that you can deploy patches, know the status, the memory usage, whatever. You have to know everything. Then you need to secure it from the outside world, as I said, because the outside world is evil. You want to monitor everything. You want to be the first one to know when something is broken. You don't want customers to react and say something like, hey, this doesn't work. If the support calls, you want to go and say, yes, I'm already on it. We have already fixed it, maybe. Even that would be the best. And you need to provide a good API, because otherwise you would just be stuck with the low-level PSE, and that's just not fun to program, at least not for me. Maybe some people have fun. And the most important, everything is most important, but the most important thing is use events abundantly, because without that, nothing of the above could actually work, because you don't know what's going on there, and you don't want to make synchronous calls, because this is just too error-prone. All right, I think I have some technology we're using, but that's not super interesting. Yeah, very solid stuff. Using Keycloak for authentication, which is maybe interesting for some of you. But actually, that's all I got. Thank you.